Good morning, class. I'm going to go over some laws of exponents. Okay, so let's see here. The first thing that you need to know about laws of exponents is exponent and base. Okay, remember, multiplication is a faster way to add. Evaluating exponents is going to be a faster way to multiply. So if I have 3 to the second power, this is saying that I'm going to multiply 3 times itself 2 times, okay, or one other time. So this looks like, remember, this is my base and this is my exponent. The exponent tells the base, it tells you how many times to multiply the base. So I'm going to multiply the base twice. So this is going to be 3 times 3, or one other time, in other words. So 3 times 3 is going to give me 9 if I'm simplifying it completely, okay? With some laws of exponents, it's not necessary to simplify completely. And I'm going to show you that here in a minute. All right, so now that we have established the relationship between an exponent and a base, we're going to do some laws of exponents. The first law of exponent that we are going to do is called multiplication. We're going to multiply those exponents that have like bases. That means that the bases are the same. In number 1, the base is 4 here and 4 here. So when the bases are the same, this is what that looks like. 4 to the second power is the same as saying 4 times 4. Again, bring this down, times. 4 to the second power is the same as saying 4 times 4. And remember, like I just said, exponents, or evaluating exponents, is a faster way to multiply. So here, how many times is 4 being multiplied? 4 is being multiplied a total of 1, 2, 3, 4 times. So my answer is going to be 4 to the 4th power. I'm not going to simplify completely here. I want my answers to be written in exponent form, okay? Before, I simplified completely, and I got 9. But here, it's not necessary to simplify completely. I just want to write it in exponent form. So the shorter way to do this, besides breaking it down in this way, in expanded form, we can just add the exponents together if the bases are alike. Now you can't do this if the bases are not alike. So we have 4 as my base, the bases are alike, and we're going to say 2 plus 2. 2 plus 2 is going to give me 4. So this is my shortcut. This is my expanded form, and this is the shortcut. So let's do this one. Number 2, when you don't see an exponent on a base, the exponent is automatically 1. The expanded form would be to write it in this way, which this would be 4, because 4, the exponent is 1, so you're just going to write it 1 time, times 4 to the second. That means you write 4 twice, 4 times 4. 4 is being multiplied a total of 3 times. So that's going to be 4 to the third. I'm going to keep it in exponent form. The shortcut way, this was the expanded way. The shortcut way, when the bases are alike, only when the bases are alike can you do this. You will say 1 plus 2. Okay, so my answer here is going to be 4 to the 3rd power. Again, 4 is being multiplied. We got 1 time, and 4 is being multiplied 2 times. So 4 is being multiplied a total of 3. All right, so let's look at this one. We have, again, 3 to the second power, 3 to the second power. We're going to do the shortcut way instead of doing the expanded form, because I think we got the idea of how to do the expanded form. If not, rewind the video and watch it again, okay? So shortcut, 3 is being multiplied 2 times here. So we got 2 plus 3 is also being multiplied 2 times here. So that's going to be 2 plus 2, which is going to be 4. So it's going to be 3 to the 4th power. We're going to do the same thing here. Remember, when there's no exponent, when there is no exponent attached to the number, it's automatically, or to the base, it's automatically 1. All the bases are alike here, so we could add the exponents together. So we have 1 plus 2 plus 2. So this is going to give me 2 to the 5th power. Okay. Number 5. This one looks a little different from the other ones. So what you're going to do here, the bases are not alike for this number and this number, so you simply multiply them. We got 2 times 5. 2 times 5 here is going to be equal to 10. So we got 10. Okay. Then we have the bases here are the same with the ends. So we got n to the 4th and then n to the 4th. So we can add 4. N is being multiplied 4 times here. N is being multiplied 4 times there. So my answer here is going to be 10 n to the 8th power. Okay. Let's do the next one. Here, we are going, again, the bases are not alike in these two numbers. So we're just going to simply multiply them together because this is multiplication here. So we have 6 times 5, which is 30. The bases are the same here for the r. Remember, when you don't see an exponent, your exponent is 1. So you're going to have r 1 plus 2. So this is going to give you 30 r to the 3rd power. Okay? So that's multiplying exponents that have the same base. When you multiply exponents that have the same base, you're going to add the exponents. Okay? All right, so let's move on to dividing. All right, let's divide. Okay, so when you are dividing the exponents, the expanded form looks like this. Okay, so your numerator, again, is saying, is the top number. This is saying 5 to the 4th power. That means we're going to multiply 5 4 times. So that's 5 times 5 times 5 times 5. Okay? On the bottom, we're just going to have 5. Okay? All right, 5 is written one time. The exponent that is automatically there is going to be 1. Okay, so that's why we're only going to write, one time. All right. So here, when we divide, we're going to divide. We have 5 divided by 5. When you divide 5 divided by 5, that gives you just 1. Okay, that's 1. So now what we have on the top, the numerator, 5 times 5 times 5. 5 is being multiplied on the top 3 times. So now we have 5 to the 3rd power. On the bottom, it's just a 1. We could put a 1 here on the bottom, but that's still going to be 5 to the 3rd power. That's the expanded form, okay? The shortcut way then would be, since the bases are alike, you can subtract the exponents. Remember, if you don't see an exponent, it is automatically 1. So we got the base of 5. The top number is 4, so it goes first. This is 4. The bottom number goes second. This is 1, so we're going to say minus 1. So my answer here is going to be 5 to the 3rd power. Okay? 5 to the 3rd power. So when you are dividing exponents that have like bases, you're going to subtract the exponents. Okay, so that means you got to know your rules for integers as well, okay? All right, so let's do this one again. Let's do the expanded form. Remember, this is the expanded form. This is our little shortcut. So here on number 2, if you don't see an exponent, the exponent is automatically 1. So with the expanded form, on the top we have 3 to the first power, so we just write 3 one time. On the bottom we have 3 to the third power, so we're going to write 3 3 times. 3 times 3 times 3. Now we're going to divide. So when we divide 3 divided by 3, this is going to give us 1. So on the top here, we're going to have 1. On the bottom, 3 is being multiplied 2 times. So this is going to be 3 to the second power. This is going to be my answer. Okay? All right. So let's look at how to do the shortcut. The bases are alike. The top number is 1, so we got 1 minus the bottom number is 3. Okay? So this is going to be 3 to the negative 2 power. Now notice that the exponent is negative. When you have a negative exponent, you write this answer as a fraction, where you have 1 over now 3 to the positive 2. So you can't keep the exponent-base relationship. You can't keep it like this. You don't want a negative exponent. So in order to simplify this, you're going to write it as a fraction. 1 is going to be your numerator. And when you move this exponent base down to the bottom, the exponent then becomes positive. So that's going to be your answer. And that's what you do when you have a negative exponent. You just simply write it like this. Okay? If I simplify these completely, I say 3 times 3, and that gives me 9, so that's 1/9. Okay? So if you type it in the calculator, you're going to get 1 over 9. But we want to keep it in exponent form. Let's look at number 3. Let's do this the same way. Expanded form is going to be 2 times 2. That's for the numerator. The expanded form for the bottom, since the exponent is 3, it's going to be 2 times 2 times 2. Okay? Now we're going to divide. 2 divided by 2 is 1. 2 divided by 2 is 1. On the top, we have 1 times 1, which is 1. And on the bottom, we just have a 2 left, so we're going to write 2. All right, so this is going to be our answer. The shortcut way, since the exponents, the bases are the same, you can subtract the exponents because you're dividing. So that's going to be 2 minus 3. 2 minus 3 is going to give me a negative 1. Again, you got a negative exponent, so you're going to write this as a fraction to make the exponent positive. You got 1 over, just bring this down to the bottom. And when you bring it down to the bottom, the exponent is now going to be positive. You don't have to write the 1 there. Okay? All right. Let's look at this one. Now you have 2 to the 4th power is our numerator. Okay? So that means I'm going to write 2 4 times. Okay? All right. So now this is going to give me, on the bottom, 2 times 2. So now I'm going to divide. So when I divide, 2 divided by 2 is 1. 2 divided by 2 is 1. So on the top, we have 2 2s, so that's 2 to the second. On the bottom, 1 times 1 is going to be 1. So another way to write this is just to say 2 to the second power. That's the expanded form. Shortcut, we write this as 2 is the base. Your numerator exponent is 4, so that's going to be 4 minus bottom number 2, or bottom exponent is 2. So when I subtract this, this is going to be 2 to the second power. Okay? All right, let's look at Number 5, these look a little different. The bases are not the same in the numbers, so you just divide. 2 divided by 3, I'm just going to keep it as the fraction. 3 divided by 2. 3 is on top, excuse me. The bases are the same here. I could change this into a decimal if I want to, okay? 1.5, you can do that if you want to, or you can just keep it as a fraction. It's okay to keep it as a fraction. Here, I'm going to, I have 3 R's on the top. And do the expanded form first. R, 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 R on the bottom. When I divide the R's, R divided by R gives me 1. So what's left on the top is 3 R to the second. Okay? On the bottom is 2. In shortcut, you do the same thing. Divide the number, 3 divided by 2. Keep it as a fraction. And you're going to subtract 3 minus 1. The exponent here is automatically 1 if you don't see 1. And so this in terms will give me 3. When you subtract, this gives me R to the second over 2. All right. Let's do this one. 7. 7 over 4. You can keep it as a fraction. 7 over 4. Okay. Or you can divide and get your decimal. Let's do the expanded form. So this is going to be times K times K. Okay. On the bottom, this is going to be K times K times K. When you divide, you keep it as a fraction. That gives me 7x, not x. Divide here, that's 1. This is 1. So on the top, all you get is the 7. On the bottom, what you get is 4K. And this is your answer. Your shortcut, divide, you can keep it as a fraction. As long as the fraction is reduced, then it is. K, you got 2 minus 3. 2 is on top, that goes first. 3 on the bottom, that goes second. This is going to give me 7, 4, K to the negative 1. Notice that the negative 1 is attached to just the K. So in order to make it positive, you're only going to move the K down to the bottom to make it positive, okay? So this 7 stays up top. It has a positive exponent of 1. Keep it on the top. 4, keep it where it is. Just bring the K to the first power down to the bottom to make it a positive 1. And again, you don't have to put the positive 1 there. Okay? Your last is the power of a power. When you have a power or exponent raised to another exponent, you're simply going to multiply, okay? All right, so look, where's my little sheet? You're going to multiply the exponents together. Let me show you why that works, okay, before I get to these. All right, so power of, which is multiplication, power of a power. So if I have, let's say 5 to the third power times 5, power of power, Ms. Reyes, times to the fourth power. A way to write this is to say, look, the expanded form of this is 5 to the third 4 times. So that's 5 to the third times 5 to the third times 5 to the third times 5 to the third. And I wrote that 1, 2, 3, 4 times because the exponent is 4. Okay, so here 5 is being multiplied 3 times. That's 5 times 5 times 5, right? And then it's multiplied 3 times here again. It's multiplied 3 times here again. And lastly, it's multiplied 3 times here again. Okay? So 5 is being multiplied a total of 1, 2, 3 for this one. 5, 6, wait a minute. Sorry. 1, 2, 3. Lord, Miss Reyes, really? 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 5 is being multiplied 12 times. Okay? All right. That's the expanded form. So the shortcut way to do this, okay, is when you have a power raised to another power, you multiply the powers together. So this is going to be 5, 3 times 4. So 3 times 4 is going to be 12. And that's really much easier than doing all of this, okay? All right, so let's look at this. Number 1, the exponent on that 3 is automatically a 1, all right? So here's what you have. You're going to take 3 and multiply it times all the exponents in the parentheses. So that's going to be 3, 1 times 3, and that's going to be a 2 times 3. Sorry. So then this is going to give me 3 to the 3rd power, a to the 6th power. You can go ahead and multiply 3 times 3, which is 9, and then 9 times 3, which is 27. You could do that or keep it like this. 27, a to the 6th. Either one is okay. All right, so let's do this one. We have 4 as the exponent, power raised to a power. The exponent here is 1. So 4 is also, you have to do all the numbers and variables in the parentheses. So that's going to be 2, 1 times 4, n 4 times 4, okay? So this is going to be 2 to the 4th power, n to the 16th power. And that's going to be your answer. You can simplify that. You can simplify the 2 times 2 times 2 times 2. 2 times 2, we got 4 here, so that'd be 16. Or, again, you can just keep it like this, okay? All right. For this one, do the same thing again. You have 3, 1 times 4, x 4 times 4. So your answer here is going to be 3 to the 4th power, x to the 16th power. All right, and those are how you do, and that's how you do those problems, okay? All right, love y'all. Have a good day.